Hey, calculus class. I know you miss me, so I'm here to make a video for you. Miss all of you. Instead of some boring guy going over it, you got me. Antiderivative exit slip. I just wanted to go over the answers to what you did yesterday. Hopefully you got them all right. If you had no clue what you were doing yesterday, I haven't seen it yet. I haven't looked at it. All your turned in work, but hopefully this really helps. Got another one for you today to do. All right, ready? What is the antiderivative? The antiderivative is the reverse of taking the derivative. So we have to reverse the steps. In the derivative, we multiply so when you had, I'll just go through an example. If you had 3x squared and you took the derivative of 3x squared, the power rule states multiply 2 times 3 and then to subtract 1 from the exponent. So 2 times 3 would be 6, and this would be x to the first. The antiderivative, we are reversing those steps. So instead of multiplying the coefficient and then subtracting from 1, we are going to be adding 1 and then dividing by the new exponent. So starting with number 1, we have this funky looking symbol here. This is an integral symbol. It means antiderivative. It's going to mean a lot of other things. We're going to be using this now until the end of the semester, end of the year. All right, so we have the integration or antiderivative of negative 12x to the 5th dx. You're probably wondering what this funky little dx is. This means that the derivative was taken in respect to x. So the derivative was taken in respect to x. You're going to see this in all of the problems. Just kind of ignore it for now, all right? So first step, we are going to add 1 to the exponent. So the antiderivative of this is going to be x to the 6th. And then we take our new exponent and we are going to be dividing the coefficient from it, or by it. So negative 12 divided by 6 is negative 2x to the 6th. Now something else I want to add too, you have to add into all of your answers a plus c. That is to take into account, pay attention now, that's to take into account the constant that might have been lost when taking the derivative. All right, so if I gave you this equation, let's say it was negative 2x to the 6th plus 7. 7 was the constant. If I took the derivative of negative 2x to the 6th plus 7, it would be negative 12x to the 5th, and the derivative of 7 would be 0, and it would go away. So when we take the antiderivative, we go back the other way, there is no possible way to figure out that that was a 7 or not. So we write plus c. That plus c stands for a constant lost. So when I ask you what the c represents, you say it represents the constant lost when you took the derivative. All right, on to the next problem. Nice easy problem here. We have the integration or antiderivative of 3, and its dx means we took the derivative with respect to x. So I know to use an x when I'm taking the antiderivative of this. So another way to look at this, and which was explained in the video you watched, was 3x to the 0. So 3 is really 3x to the 0. So we have to add 1 to the exponent. So that's going to be x to the first, and then divide the coefficient by that new exponent. So 3 over 1 is 3, and x to the first is just x, but we cannot forget what? The plus c. All right, we have enough room here. We can do number 3. Number 3 is the antiderivative or integration of negative 6x to the negative 3 dx. You have to be very careful here when you have a negative exponent. Make sure you are adding to it. All right, negative 3 plus 1 is negative 2. And then we have negative 6 divided by that new exponent. Negative 6 divided by negative 2 is 3. So that would be 3x to the negative 2. Now, 3x to the negative 2, I'm fine with you leaving it like that, but we have to put the plus c. Another way you might leave your answer is 3 over x squared plus c. I'm fine with you writing either of this. This is less work. You can leave it just like that. All right, moving on to some slightly harder problems. And number 4 might be something that you look at and you say, whoa, what is that? Why is the x down below? Just as we did with our derivative, we have to move that up, all right? So we move that up by rewriting this as 10x to the negative 3 dx. Notice I keep that integration there because I haven't formed the antiderivative yet. So that symbol telling me that this is the derivative of something and I need to take the antiderivative of it. So we are going to add 1 to our exponent and then divide by our new exponent. So 10 over negative 2 would be negative 5, x to the negative 2. And we have to make sure in our final answer, we add in that plus c. Moving on, number 5. Number 5, we have the integration of 7x to the 3/4 over 4 dx. This right here might be a little confusing again. That 7x over 4, I personally would rewrite this as 7/4 x to the 3/4 dx. Okay, that makes it seem a little better. Now I have to add 1 to 3/4. Now adding 1 to 3/4, you have to think in fractions. How many fourths is equivalent to 1? That would be 4/4. So this would be 7/4. Now we have to take 7/4 and divide it by 7/4, which would be 7/4 times 4 over 7, x to the 7/4. But 7/4 times 4 over 7 becomes 1. So that'd be 1x to the 7/4 plus c. All right, fractions are a little bit difficult. You got to brush up on your adding and dividing by a fraction. When we divide by a fraction, I have to keep change flip. So dividing by a fraction is the same thing as multiplying by the reciprocal. All right, next problem. We have the integration or antiderivative of 5 times x to the 4th root of x dx. I know it's been a while, but we have to remember how to turn this into a rational exponent. Remember, whatever the power the x is raised to is the numerator, and then this number would be the denominator. So this would be the same thing as the integration of 5x to the 1/4 dx. So what we have to do is we have to add 1 to 1/4. So we'd be adding 4/4 to that, which would become 5/4. So then I would have 5 divided by 5/4. So 5 over 1 times the reciprocal of 5/4 would be 4/5 x to the 5/4. Now 5 over 1 times 4 over 5. You can think of it as 20 divided by 5, or you could think of it as the 5s who cancel out, and I would have 4x to the 5/4 plus c. All right, the last 2 problems I gave you are just the same rules, except we're going to have more terms that we're doing in it. Obviously, the antiderivatives aren't always just a single term, we're going to have to apply these to a polynomial as well. Just popped in my head. Hopefully I remember to put a plus C at the end of that last problem. Make sure I put a plus C there. Don't ask me if I put a plus C. Hopefully I did. You have to put a plus C at the end of these. All right, moving on. Here we have a polynomial, the antiderivative or integration of a polynomial with respect to x. Same thing we were doing. We got to treat these all as individual problems. You might see in a book somewhere that they rewrite each of these with a symbol in front of it. So the integration of negative 5x to the fourth, plus the integration of 9x squared, plus the integration of negative 10x dx. Right? We're not going to do that. We just have to treat these individually, follow that power rule for each, or the reverse of the power rule for each. So this is going to be x to the fifth, adding 1 to the 4, and then we would be dividing by 5. This we would be adding 1 to the 2, and then dividing 9 by 3. This problem, we would be adding 1 to the 1, and then dividing by 2 plus c. Simplify this down, negative 5 over 5, that'd be negative 1x to the fifth, plus 3x to the third, minus 5x squared, plus c. One more problem to do. Last problem again, we have the polynomial. These parentheses right here, I know the particular worksheet maker I have puts in, you do not need those parentheses there. So if you see it with or without those parentheses, it doesn't make a difference. All right, so we have the integration of 30x to the fifth plus 9x squared plus 5 dx. We took the derivative of it with respect to x. So we have x to the sixth, and then 30 is going to be divided by 6. All right, plus this is going to be x to the third, and then 9 divided by 3. And then this would be x to the 0. So this would be plus 5x to the first divided by 1 plus c. Then just simplifying these, we have 5x to the sixth plus 3x to the third plus 5x plus c. All right. I hope you enjoyed this as much as I did. Miss you all. Send me some messages. All right, communicate. If you ever need anything, let me know.